Hey everyone, I'm going to use this video to solve equilibrium force problems. In order to do that, we're going to start with the equation that you guys got from your lab. Fg is equal to the gravitational field strength times mass. Fg is really just the force due to gravity or weight. That equation, Fg is equal to the gravitational field strength times mass, you'll hear us usually say Fg is equal to little g times m. On your equation sheet, it's going to look like that. Here on Earth, little g is going to be 9.8 newtons per kilogram. We're going to use 10 just because the number is easier. You can use 10 on everything that we do, including the AP exam, except for mastering physics, which really shouldn't come as any surprise given all the troubles we've had with mastering physics. When we're looking at equilibrium problems, there are going to be two different types of equilibrium. Static, meaning that our object is at rest, or dynamic, meaning our object is moving with a constant velocity. Both of these tell us that our acceleration is zero. When our acceleration is zero, we know that our forces must be balanced. Because we know that if our acceleration is zero, then our net force must be zero, which really just means our forces need to be balanced. In order to solve static or dynamic equilibrium problems, we're going to go through a series of steps. The first step is going to be to draw a force diagram. If there are any forces that are at angles, we will split them into perpendicular components by drawing a right triangle. We're going to do that off to the side. We're not going to do that on our force diagram. In fact, on the AP exam, if you were to do it on your force diagram, they will actually take away points. After we've done that, what we're going to do is we're going to look at all of our different forces, and we're going to write equations to show the balance. We're going to do it in the x direction, setting up all of our forces to the left, equaling all of our forces to the right, and we're going to do it for our y direction forces, saying that all of our forces up are going to equal all of our forces down. Then we're going to solve for any unknown forces using trig. Our Fg is equal to little g times m, and the equations that we set up in 3, our left equals right and our up equals down. Let's take a look at a basic equilibrium problem. Okay, pulling a wagon. A child pulls a 5-kilogram wagon at an angle of 20 degrees above the horizontal with 40 newtons of force, making the wagon move at a constant velocity. Solve for all the missing forces. Now, this moving at a constant velocity is actually really important to our problem, and you'll see why in a second here. We're going to draw all of the forces that are going to act on our object. Let's start with creating our object. Remember, we can always just put it as a dot. And let's draw our forces that we know are going to be acting on our wagon. We're on Earth, so we know we've got our force of gravity down. We're on a surface, so we know we've got our normal force up, which would be perpendicular to our surface. And we've got our tension force coming from the pulling of the handle up in that direction. Now, a lot of times we ask ourselves, are we going to include friction or not? Because of the fact that we know we've got forces to the left, and if we go back, that's where this constant velocity part comes into play. We have forces going to the left. The only way we can move with a constant velocity is if we also then have some sort of a force going to the right. So we are going to include friction here. So there's our first step. Our second step is going to be to break down any angled forces into its components. The only force that we have at an angle is the tension force. So we're going to break it into its perpendicular components by creating a right triangle. Once we've done that, we're going to name our forces. We're going to call our y component FTY and our x component FTX. And really, we're able to do that because this force from the tension that we have is both pulling up and to the left on the wagon at the same time. So we can break it down into the force that's pulling up and the force that's pulling to the left. Notice I did not draw the components on my force diagram. You can if you draw a second force diagram, but you cannot draw it on your original. AP will take off points for that. Once we have our triangle and we have our components drawn in, we can draw in our angle. We know that that angle is 20 degrees because it tells us it's at 20 degrees to the horizontal. And we need to go about finding out what our components are. Well, we know that the tension force itself whoops, I'm sorry. I wrote down 20 and I meant 40. So let's take that back. My angle was 20 degrees. So my tension force was 40 newtons. I want to know what my x and my y components are. And this is where we're going to use some trig. So just as kind of a quick review as far as our trig goes, we're going to throw in an extra little page here. And let's look at a right triangle. If I call this my angle, if I call that my angle, we know that this is my hypotenuse. If this is my angle, this is my opposite side, and this would be then my adjacent side. Right? We're going to use SOHCAHTOA in order to figure out what the different things are. Keep in mind that SOHCAHTOA tells me that my sine is equal to opposite over hypotenuse. My cosine is equal to opposite over, adjacent over hypotenuse, and that my tangent is equal to opposite over my adjacent side. We are going through this kind of quickly. It is assumed that you are comfortable using your trig, at least your 3 trig functions here. What that tells me is if I want to know my opposite side, I'm going to use that my sine, and if I call that theta, my sine of theta is equal to opposite over hypotenuse, which means my opposite side, I'm going to multiply both sides by hypotenuse, telling me that my hypotenuse times the sine of theta is going to tell me what my opposite side is. If I translate that into up here, that tells me that FTY is equal to FT times the sine of 20 degrees. Jumping back down here, because I want to find my adjacent side, I know that the cosine of theta is equal to my adjacent side divided by my hypotenuse. When I want to find my adjacent side, I'm going to multiply both sides by the hypotenuse, and I get that the hypotenuse times the cosine of theta will give me my adjacent side. That tells me that my FTX then would be equal to FT times the cosine of 20 degrees. I'm going to use those in order to determine what the magnitudes of my other forces are. Now, if you remember, we said we're going to set up our equations, right? We're going to bring the fact that we're balanced tells us that left is equal to right and up is equal to down. All of my forces to the left are going to equal all of my forces to the right. Well, if you remember, I'm going to go ahead and let's redraw my force diagram, this time with the components in it. Fg, I've got my normal force, I've got my tension force, and I've got my force of friction. Let's make that a little neater there. And then I'm going to break it down. Let's change colors here so that our components really stick out. Ftx and Fty. That shows why I have it set up here that Ftx is equal to the force of friction. And if you look at my up and down, Fty plus my normal force, those are all of my up forces, right? My Fty has an arrow pointing up, my normal force has an arrow pointing up. Those are going to be equal to all of my down forces, which just happens to be Fg. Now I'm going to solve my equations, right? We know, and this is an always, one of the few always that we can use in physics, Fg is always equal to mg, which in this case is going to be equal to my 5 kilograms times my 10 newtons per kilogram. Kilograms will cancel, and I get 5 times 10 gives me my 50 newtons. Right, that's going to tell me that my force due to gravity is 50 newtons. My normal force plus my Fty is going to be equal to 50 newtons. My Fty I know to be 40 times the sine of 20 degrees. That'll tell me what my y is equal to 50 newtons plus my normal force. Plugging 40 times the sine of 20 into my calculator will tell me what that is, and I can figure out the rest of that. Plug that into my calculator. 40 times the sine of 20 is 13.7. Tells me that my normal force plus 13.7 is equal to 50 newtons. So I'm going to subtract that from each other, and that tells me that my normal force then is 36.3 newtons. And I've now figured out my normal force. My gravity. So now the only thing I have left is my force of friction. Well, my equation up here tells me that my force of friction is equal to Ftx. So once I can figure out my Ftx, that tells me what my force of friction is. And my Ftx is just going to be 40 times the cosine of 20 degrees. And that tells me times the cosine of 20 degrees is equal to my force of friction, and that number works out to be 37.6 newtons is my force of friction. And now I can go back in and I can plug that in. Whoops, excuse me. 37.6 newtons. I have now used all of my equations to figure out my missing forces. The only thing I was given was the mass of the cart and the tension force. The rest of it came from using my left is equal to right and my up is equal to down, right? Anytime I'm dealing with equilibrium, those have to work out to be the case, right? Balanced forces mean left equals right, up equals down. Notice, and I know we've talked about this in some of the classes, balanced forces does not mean that all of the forces are equal to each other. It just means that all of my lefts equal all of my rights and all of my ups equal all of my downs. But all of the individual forces don't have to be equal to each other. Okay, good luck with this. There's some more problems for you to practice on, and we shall see you soon.